Hey everyone, Mr. Fransky here. Today we're going to talk about 4.2a, which is just right triangle trig. You guys have seen this before, I'm sure of it. You could probably skip this video, but there's one example at the end that I kind of make sure that you see. So you can fast forward through it, just watch it fast. It's just fine. So like I said, you already know it. If you have a right triangle, you have a reference angle theta. This is the opposite side, this is the adjacent side, and this is the hypotenuse. So adjacent means next to. It's next to the angle, but it's not the hypotenuse. The hypotenuse is always the one across from the right angle. Opposite is always the one opposite of the angle you're talking about. So sine of theta, so that is S-I-N-E, right? Sine, but the abbreviation is S-I-N, is the opposite over the hypotenuse. So it's a ratio of the side lengths, which is O over H. Cosine of theta is the adjacent side over the hypotenuse, or A over H, and tan theta, tangent, so we have sine, cosine, and tangent. Okay. Tan of theta is the opposite over the adjacent, which is O over A. So the way you remember it is with SOHCAHTOA, S-O-H-C-A-H-T-O-A. So maybe TMI, but when I was in middle and high school, I did a lot of hiking, and I had boots that didn't fit me very well, and I got ingrown toenails, so a little bit of Mr. Fransky side story for you. And I had to soak my feet in Epsom salt. Epsom salt is this stuff that basically heals infections, and so because around that time I was learning trig, I would always say I had to soak my toa, because it's SOHCAHTOA. All right, moving on. Anyway, so the other functions, this is just 3 of the 6. There are really 3 more trig functions, are secant, cosecant, and cotangent. So I'm going to write them here: secant, cosecant, and cotangent. And everyone always thinks that trig has to do with triangles. Trig actually has to do with the unit circle, which we're going to learn in the next video. It is kind of easier to talk about unit circle if you already have a knowledge of this. The reason that, because everyone always forgets which one is which. Cosecant is 1 over sine. 1 over sine theta. Secant is 1 over cosine. And everyone's always like, why was that? Because it seems like the cos should go together. Secant and sine should go together. It's because of the way the unit circle is laid out. The secant line actually has to do with the reciprocal of tangent, and the cosecant line has to do with the reciprocal of sine. But thankfully, cotangent theta, theta there, is equal to 1 over tangent theta. So cosecant, if it's 1 over sine, that's going to be hypotenuse over opposite. Secant theta, 1 over cosine, it's going to be hypotenuse over adjacent. It's an H. And then 1 over tangent is going to be opposite over adjacent. Nope, adjacent over opposite, excuse me. Okay, so no one, I don't think there are very many people that teach this at all. I might be one of the few teachers in the nation, but this is SHOHCAHTOA. SHOHCAHTOA. Right? Usually people just remember it's the reciprocal of the sine, cosine, and tangent functions, but SHA, secant, hypotenuse over adjacent, CHO, cosecant, hypotenuse over opposite, cow, C-A-O. So SHOHCAHTOA. Sounds like someone shot a cow. I don't know. Anyway, this is helpful. SOHCAHTOA, SHOHCAHTOA, pretty nice for finding trig ratios. There's one other thing that you'll sometimes see. Tan theta is equal to sine theta over cosine theta. You can prove it using the hypotenuse and the opposite and the adjacent. Tan is opposite over adjacent, so if you do sine over cosine, you'd multiply by the reciprocal here. The hypotenuse would cancel. You'd have O over A. And cotangent then is cosine over sine. Some nifty little identities that we're going to use a lot later in the chapter. Alright, so let's try one. So find all 6 trig functions of theta. So let's see if you can do this. Sine, cosine, tangent, secant, cosecant, cotangent. You can pause the video and try this yourself. See if we can do them together. So sine theta, sine SOHCAHTOA. We go SHOHCAHTOA. So SOHCAHTOA, sine opposite over hypotenuse, 3/5. Ka, adjacent over hypotenuse, 4/5. Tangent opposite over adjacent, 3/4. 3/4. There we go. Secant is going to be hypotenuse over over adjacent. Sha chokao. Hypotenuse over adjacent, which is 5/4. It's 1 over cosine. Notice it's reciprocal with the cosine function. Cosecant, cho, hypotenuse over opposite, 5/3. Reciprocal of sine. And cow, adjacent over opposite, 4/3. There you go. That's all there is to it. This one's a little bit different spin. We have some special triangles here. So this is one that has two side lengths that are the same. So let's call them x and x. If this is x and this is x, then this we can solve by Pythagorean theorem. X squared plus x squared equals, let's call it z squared. Let's call this guy z. So this is 2x squared, because x squared plus x squared is 2x squared, is equal to z squared. So to solve for z, you take the square root. We have root 2 times x is equal to z. So this is root 2x. This is a 45, 45, 90 right triangle, often you hear it called. Okay. Two base angles are the same because we have an isosceles. It has two legs that are the same length. And this ratio will always hold for any triangle like this, no matter how big it is. The most common one you see is 1, 1, root 2. Right? If this is 1 and this is 1, this is root 2 times 1. So it's 1, 1, root 2. But you don't really have to have that to be able to find the 6 functions of this guy. Let's just do sine, cosine, and tangent. So sine of 45 would be hypotenuse, opposite of hypotenuse, x over root 2x. The x's cancel. So it's 1 over root 2. If you rationalize that, root 2 on the top and the bottom, that's root 2 over 2. You may have seen that value before. It may ring a bell. Cosine of 45 is adjacent over hypotenuse. Now notice it's the same as the opposite of hypotenuse. So it's still x over root 2x. X's cancel. It's still going to give us root 2 over 2. Tangent of 45. Tangent of 45 opposite over adjacent. X over x is 1. Okay, so nice to know these ratios for 45, 45, 90 right triangles. That comes up a lot. 30, 60, 90 is also one that you see a lot. You should give x to the shortest side. And then, if you remember, you may have heard this is a 1, 2, root 3 triangle. I'm not going to go through the proof of that right now, but you actually have to use, I think, law of sines to be able to do it. So if this is x, this guy right here is going to be our 2x, and this is going to be root 3 times x. So let's do things on the 30. Let's do sine, cosine, and tangent of 30. So sine of 30, opposite of hypotenuse, x over 2x. X's cancel, 1/2. Again, you could do this with a 1, a 2, and a root 3. That's the most common one you see because that an x is 1. But this works for any 30, 60, 90 right triangle, big as you want it to be. It could be like 7, 14, and 7 root 3. Right? Cosine of 30, adjacent of hypotenuse, root 3x over 2x. That's root 3 over 2. Hopefully these values are ringing a bell. We're going to see them lots in the next couple of weeks. Tangent of 30, opposite over adjacent, x over root 3x. X's cancel, it's 1 over root 3. And if we rationalize, root 3 on the top and bottom, root 3 over 3. I'll leave it up to you guys to do it for 60. Same idea though, right? These would all just be flipped. Okay. Sine would be root 3 over 2, cosine would be 1/2. Tan 30, I believe, is root 3. Tan 60, excuse me. I think I got one more example. So if theta is acute and sine of theta is 5/6, find the 5 other trig functions of theta. So this idea of theta being acute, we'll talk more about potentially having obtuse angles later on. So looking for the 5 other functions. So we're told it's acute, so that means it'll fit inside a triangle. That's basically the easiest way to think about that. Because if it was obtuse, then you wouldn't necessarily be able to do a right triangle with it inside. So tell us that sine of theta is 5/6. That's opposite of hypotenuse. Let's just put them in. 5 and 6. I think we can solve for that last one by using Pythagorean theorem. Let's call it x. We have 5 squared plus x squared is 36. So 5 squared is 25. Subtract from 36. That is 11. So x squared is 11. So x is root 11. Mean numbers. Okay. So they want the other 5 trig functions of theta. We've got sine, so we need cosine. We need tangent. We need secant, cosecant, and cotangent. Alright, so our cosine, adjacent over hypotenuse, root 11 over 6. Tangent, opposite over adjacent, 5 over root 11. And if we rationalize that, it's going to be 5 root 11 over 11. Secant, let's see, sha, hypotenuse over opposite, 6/5. Should be the reciprocal of this guy, that makes sense. Oh, nope, that's something wrong. Opposite over hypotenuse, that's sine. Secant, sha, hypotenuse over adjacent, that's what's wrong. That should be root 11 on the bottom. If you rationalize that, it'd be 6 root 11 over 11. You do a few of these, the rationalization starts to become really easy. Cosecant, cho, hypotenuse over opposite. That's the 6/5. Yep, that makes sense. Reciprocal of sine. And then cotangent can be just flipped over tangent. It's going to be root 11 over 5. There we go. All right. So hopefully this was helpful. A little bit of review on SOHCAHTOA, SHOCHOCAHO. And that's all I've got for you. I love you guys. That's why I'm here. Have a great day. Enjoy the unit circle video.